Let's look at precision and accuracy. This is still under the theory of errors. If you have not been following this video from beginning, kindly check the description box below to see the link of theory of errors. So you start from there up to this point. Now, what is precision and what is accuracy? You need to get the difference between them and you need to get the concept very clear. Precision is the degree of closeness or agreement between replicate measurements of the same quantity. Now, let's explain this. Let me take for instance that you are trying to measure the length of a piece of wire, for example, and you take replicate measurement, like let me say you take the measurement 3 times. Now, if your measurements are very close to each other, we will say your set of data is highly precise, or we say it has high precision. Can you still remember your titration? Whenever you take your reading and you are recording the titer value, if you observe, if your values are very, very close to each other, that means that your values are precise or they have high precision. But if they are too far away from each other, we say that what your value has low precision. So if you take replicate measurement, the degree of closeness or the degree of agreement, how close your data are to each other, is what we call what precision. And what is accuracy? Now take note of something. Accuracy is the degree of closeness of a single measurement or mean of set of measurements to the true value. Now take note, precision has nothing to do with the true value at all, but accuracy has something to do with the what to the true value. Take note, precision does not relate true value, but accuracy relates what true value. Now, let me take for instance that you take just one measurement. Now, the closeness of your measurement to the true value is what we call what the accuracy. Now, if you are not taking a measurement, if you are taking several measurements, okay, let me take for instance that you are asked to take 3 measurements of that same quantity using same equipment. Now, after taking those 3 measurements, if you take the average or the mean of those 3 measurements, your result, if it is very close to your true value, to the true value presented, then we'll say what your result has what high accuracy. But if it is far, it has what low accuracy. Let's take an example to understand this very well. Let me take for instance that I have 4 students. Student A, let me say I have students A, B, C, and D. Now, student A take replicate measurement and he obtained 10.01, we have 9.98, and we have 10.02. And student B took the measurement and got 8.1, 8.2, and 8.15. And the other one we have 10.5, we have 9.6, and we have 10.3. And the last one here we have 7.0, we have 12.5, and we have what? And we have 9.0. Now I give you this value. Roughly, look at it and comment on the precision and accuracy. So let's look at the precision. But before that, before we look at the precision, let me say they are trying to measure the length of a particular object. And let me say the true length of that object, the true length, let's assume that the true length of that object they are measuring is 10 centimeter. And all these are obtained in centimeter. Now let's go. Look at student A, 10.01. We have 9.98 and we have 10.02. Let's comment on the precision. Remember, when we are commenting on precision, we have nothing to do with accuracy at all. We have nothing to do with it. Now let's look at the precision. How close are these values? Are they very close? If you look at it, yes. Because if you look at the difference between this and this and this, it's just 0.0. If you look at it, what is 10.01 minus 9.98? Look at it. This is was 0.0. Look at 0.03. This is very small. Let's see. What was 10.02 minus 10.01? This is 0.01. This is very, very small. So we'll just comment that A, the data that we have for A is what is highly precise. Why? They are very close to each other. The difference is not even up to 0.1. So that is it. Next one. Let's look at B. Are they precise? 8.1, 8.2, 8.15. Yes, you can see these values are very, very small, just zero point 0.1 or very, very small. So I would say this data obtained by B is also highly precise. They are very close to each other. But look at C. If you observe that by the time I just find the difference between this and this, let me say I have 10.5 minus 9.6. What do I have? 0.9. Very, very far. Very, very far. So C compared to other one is what it has what low precision because the value are very, very far. If you want to know high precision, it should be like 0.1 or 0.01 or zero point 0.0 and so on like that. So at least let me just say highest just have like 0.1 difference or 0.01 difference. They will say well it has high precision. But here the value is at 0.9. That's far. Next one, let's look at D. If you look at the R 7.0, 12.5, and 9.0, you all see that these values are not close at all. So we have low precision. If you observe minus, what is 12.5 minus 7.0? That will give you a 5.5. Look at it, 5.5. So this one is not precise at all. In fact, compared to C and D, C is at least more precise than D. Okay, but both of them has low precision. You can see, looking at precision, we are looking at the closeness of those values. We are looking at the closeness of those values, and that is it. Now, what is accuracy? Remember, it is the degree of closeness of a single measurement or mean of those measurements from the true value. Now, let's see. Remember, they are not making a single measurement here. They are all making replicate measurements. So I will not be using this single measurement. I'll be using what? Mean of those measurements. So let's calculate the mean of A. Let's see. The mean of A, that is add everything together and divide by 3. That's average. 9.98 plus 10.02. Then divided by 3. This gives me 10.00. So I'll take it to four significant figure. Let me just say 2 decimal places, just like I have here. Okay, let's look at the mean of B. What do we have here? Mean of B is what? 8.1 plus 8.2 plus 8.15. And if I divide that by 3, I'll have 8.15. 8.15. Next one for C, 10.5 plus 9.6 plus 10.3. What will I have? Divide by 3. This will give me 10.13. 10.13. And this, we have 7.0 plus 12.5 plus 9.0 divided by 3. Also follow me on with your calculator. So I have this to be 9.5. That's the mean of C and the mean of D. Now let's see. Look at the mean that we have here. Can you tell me which one has high accuracy? Remember, accuracy is the degree of closeness of this mean to the true value. Now let's see. Look at 10. Look at it. I have 10 here and the true value is 10. So A is what? Is more accurate. So I'll say this one has high accuracy. If you look at B has low accuracy because 8.15 from 10, that is actually far. That's about 1 point. Let's see. 10 minus 8.15. That's really far. 1.85 different. Very, very far. So you can see B has high precision and low accuracy. What can you deduce? The fact that you have high precision doesn't mean you are correct. Most time, if I see students in exam hall, see what they do. When they are doing practicals and they are plotting their graphs, let me say they've done what is correct and at least they have 3 points that were joined together. Let me say the other point was here and another point was here. What happens? They will try to like manipulate and put this one here and put this one here so that they will have a perfect straight line. You see, the implication of this thing is that you are just increasing your precision, but you are lowering your accuracy. Yes. You are just increasing your precision. So they'll say that, wow, this person have 5 points, 5 points that is in the best fit. But you are increasing your precision, but your accuracy will be what? It will be very low and you will fail it. In exam, we don't mark precision, but we mark accuracy. Take note of that. Okay. Now, Let's move on. Look at C. Look at 10.13, and I have 10 here. So 0.13, 0.1. That's zero point 0.1, and at least that is even accurate. So I will say high accuracy. 0.13. This is not 13. This is just 0.13. So zero point 0.1, and that's small. So high accuracy. And look at this. This is 9.5, and this is what? Um, this is 9.5, and this is 10. So I have low accuracy. So 0.5 is far. So you can see this one that have high accuracy. Look at it. This is 0 points away from the true value. While the second one that has high accuracy is what? 0.1 away from the true value. So A and C are accurate. So what can we deduce? Let us summarize. The summary is that A has high precision and high accuracy, B has high precision and low accuracy, C has low precision and high accuracy, and D has low precision and low accuracy. So that is it. Now, let us now explain the next point in this note. What's the next point here? Precision is always expressed in terms of deviation. The lower the standard deviation of a set of data, the more precise the set of data. You see, all these things I'm doing are just like rough estimate, okay? But there's a way to determine, and by proving it, that, oh, is it truly accurate or precise? Now, take note of this. The lower the standard deviation, let me say you calculate the standard deviation, and your standard deviation is low compared to other measurements, then you are what? Then your data is more precise. So I can say the standard deviation is inversely proportional to the what? To the precision. Your standard deviation is inversely proportional to the what? Precision. It means that if you have a lower standard deviation, you have high precision. If you have high standard deviation, you have what? Low precision. Take note of this. We'll use it to solve question in the next slide. Next one, accuracy is always expressed in terms of error. The lower the error, the higher the accuracy of the set of data. It makes sense. Remember that we always relate the accuracy to the true value. We always relate the accuracy to the true value. So if your measurement is far away from the what? From the real value, you know that what you are making what? Error. You are making what? Error. So that's why what we use. Accuracy is always expressed in terms of what? Error. So the lower the error, the higher the accuracy of the set of data, and that is it. So I can say what? My error is inversely proportional to the what? Accuracy, and that is it. So the lower the error that you make, it means that what you are having higher accuracy, and the higher the error, it means you are having a lower accuracy. Now, since we know all this, since we understand all this, now let's solve the next question in the next slide. Now, see what we have. A coin has an acceptable diameter of 28.054. This is the true diameter of the coin. Now, let's continue. In an experiment, two students measured this diameter. Student A used a micrometer to measure, while student B used a plastic ruler. Their results are tabulated below. I'll write it. So what is the average diameter and percentage error in each case, and comment on the accuracy and precision of the student. Good. If you're able to understand it, then you understand everything on it. So let's look at it. We have student A and B. So we have student A. Let me use another color to write that. We have student A and we have student B. Good. Student A is, we have 28.246. Here we have 28.244. Here we have 28.246. And here we have 28.248. And this we have 27.9. And we have 28.0. And here we have 27.8. And here we have 28.1. Now take note of something. You see, you can observe that they actually use different instruments. Look at this one. We have like 3 decimal places in millimeter, you can see. Why this one just 1 decimal place? So this is a ruler and this is a micrometer screw gauge. Okay, What are the average diameter and the percentage error in each case? Now let's solve. These are the value for A and these are the value for B. So what is the average? Average means you are asked to calculate the mean. So for student A, what is the mean of student A? That is, add everything here divided by 4, because I have 4 values here. So I have 28.246 plus 28.244 plus 28.246 plus 28.248, then everything all over 4. So what do I have here? Student A, the mean of student A will be equal to what? 248. So that will be equal to 28.246. And this is the mean of student A. And what is the mean of student B? That's equal to what? 27.9 plus 28.0 plus 27.8 plus 28.1. Everything all over 4. And the mean of student B will be equal to what? The mean of student B will be equal to, that will be 28.0. 28.0. So that's the mean. 28.0. Let's cross check that. 27.9, 28.0 plus 27.8 plus 28.1 divided by 4. So now the reason I'm keeping my answer this way, calculator will give you 27.95, but the reason I'm keeping my answer to one decimal place is because what I'm being given here is in one decimal place. So I'm putting this in one decimal place. This one 3 decimal place, 3 decimal place. Please put your answer that way so that you'll be more correct while solving. I'll still give us some rules that guide all this, whether to put it in the highest decimal place or lowest decimal place or significant figure. That will be in my subsequent video. Subscribe to this channel and click the notification bell. So when I release any video, you get notified. So this is the average diameter. So we've gotten the first one, we've gotten the second one. So I'll write this down and erase it. So we have the mean of A to be equal to 28.246. And we have the mean of B to be 28.0. So now we've gotten this. What's the next thing? They said, what is the percentage error in each case? So for student A, remember, let me tell you something. What is percentage error? Now, percentage error has a formula. How do we even calculate error? You see, error is equals to your measured value minus the true value. Or if you take replicate measurement, we say your mean minus the true value. You can see that. So what is the error for A? The error for A will be equal to what? The mean, 28.246 minus, what is the true value? This is it. That is 28.054. And what will be our answer? So 28.246 minus 28.054. 0.192. That's 0.192 millimeter. That's error in A. And what's the error in B? That's what? 28.0 minus 28.054. 28.0 minus 28.054. So this gives me, let me put everything I have down in calculator, 054. Let me put everything I have down in calculator. So this is what I have in limiter. This is what I have. So you can see error in A and error in what? Error in B. Good. And what is the percentage error in A? We have to calculate percentage error. So percentage error in A is equal to, remember, error in A over the true value times 100. This percentage error. Firstly, if a question asks you to calculate relative error, see relative error here. See relative error. If you just say relative error, is something like this. Is error over true value. Simple. So if you multiply relative error by 100, you are calculating percentage error. If you multiply relative error by 1000, you are calculating relative error in part per thousand. That is it. So since we are asked to find the percentage error, so this is the formula to get percentage error, and this is it. So what's error in A? That is 0.192 over the true value, 28.054. The true value is there up here, and times 100. So percentage error in what? In A, or percentage relative error in A is 0.684%. 0.684%. Okay, that's for A. So what's percentage error in B, or percentage relative error in B? Is what? Error in B over the true value times 100. And what's error in B? What's error in B? Error in B is what? Minus 0.054 over what is the true value? 28.054, then times 100. And what would this give me? That's minus 0. Approximately minus 0.19%. So this is what I have. Good. I have this. So I've gotten my error in A and error in B, the percentage error, and that is it. So this is what I have. So now since I've gotten this, I can comment on remember, accuracy is always in terms of what? Is always in terms of error. While precision is always in terms of deviation. Now, I've gotten my error, I can comment on my accuracy. Now, how will you comment on your accuracy? Can you do that? Pause the video to attempt the question. Now, you can see that what the error in A gave me what? Gave me 0.192. Gave me 0.192. 192 millimeter. And error in B gave me what? 0.054. Let me neglect the minus. Now, look at this. Can you tell me which one is more accurate? Remember, error is inversely proportional to the what? To the accuracy. I'm coming. Look at this. To the what? To the accuracy. Can you see? Error is inversely proportional to the what? To the accuracy. To the accuracy. Now let's see. It means that the one that have the smaller error will be the one that will have the higher accuracy. So can you see? Error in B is what? Is lesser compared to A. Can you see that? Error in B is lesser compared to what? Compared to A. So what will I say? Student B is more accurate. Why? Because the error in B is smaller compared to A. You don't have to say any story. Remember, error is inverse proportional to what? Accuracy. So A is less accurate. Student A is less accurate. That is it. Student A is less what? Is less accurate. As that's it. So we have commented on the accuracy. Now, how do we comment on the precision? Okay, so I will erase this now. I will erase this now. So I can still leave the mean. Okay. All right. So how do we comment on the precision? Remember, let me go back to the last slide. The precision is always expressed in terms of deviation. So I'll calculate my standard deviation for the two. So let's see. I'll draw my table. Okay. Let me do this for student A. Let me do this for student A. This is student A. Okay. The values are 28.246. The value are 28.244. The value are 28.246, and the last one is 28.248. So after that, I'll get x minus x bar. This is for student A. Don't forget that. So x minus x bar. So if I subtract that, this is what I should get. I'll have, this is 0, because with the mean, x minus x bar for student A. So that will give me 0. Here I'll have minus 0.002. Here I'll have 0, and here 0.002. And for standard deviation now, remember I will need x minus x bar square. So if I square this will give me 0. This will give me 4 times 10 raised to power minus 6. This will give me 0. This will give me 4 times 10 raised to power minus 6. They'll give me the same answer. So this is what I have. So for student A, what's summation x minus x bar square? That gives me 8 times 10 raised to power minus 6. Okay, for student A, so what's standard deviation of A? That's square root of summation x minus x bar square all over n minus 1. Remember n minus 1 from my previous video, the link is in the description box. N minus 1 is for when the data is less than 30. So after calculating this, I'll have this will give me 8 times 10 raised to power minus 6 over 1, 2, 3, 4, 4 minus 1, and that's 3. So it means that what the standard deviation of student A, the standard deviation of A will give me that's 2 times 10 raised to power minus 3, approximately 2 times 10 raised to power minus 3. So this is what I have. Okay, now after getting this for A, I'll do the same thing for B. Let's do the same thing for B. Okay. All right, let's do the same thing for B. Now for student B, let's see. So we have 27.9, 28.0, 27.8, and 28.1. So x minus x bar for student B now, x minus this will give me minus 0.1, 0. This one will give me minus 0.2, and here we have 0.1. So if you take the square, you have 0.01. So you have to be fast because of exam, 0.04, and this one will give me 0.01. So what's my summation? X minus x bar square. This will give me what? So this will give me if I add everything together 4, 5, 6, that will give me 0.06. This is what I have. So the standard deviation of B is summation square root of summation x minus x bar square all over n minus 1. So it is n minus 1 because the values are what? Less than 30. So I have square root of this gives me 0.06. Then you will square it. Like I squared the previous one also, I think, for A. You will square it all over n minus 1, and that's 4 minus 1. So you square that. Oh, sorry. I've squared it already now. No need of squaring again. So this has been squared already. So it's just over 4 minus 1. So I have standard deviation of B to be square root of 0.06 all over 3. So that gives me 0.1 approximately. So I have 0.1 approximately. Let me just leave it this way, 0.1. I have 1414. Okay, this is what I have. Okay, so let's see. Standard deviation of A is this, and standard deviation of B, and standard deviation of B is this 0.1414. And let me just put this one for you as 0.002. Yeah, 0.002. Now let's see. Standard deviation of A is 0.002, and this one is 0.1414. You can see. Looking at this, can you tell me which one is more accurate? No, which one is more precise? Let's comment on the precision. Okay, I'll give you time to do that. You can pause the video to attend the question, and when you are done, we can proceed. Now let's see. Which one is more precise? If you observe, focus that I told you that the standard deviation is inversely proportional to the what? Precision. Look at it here. Standard deviation is inversely proportional to the what? Precision. So let's see. You can see that what the standard deviation of what? Of A is less than the standard deviation of B. So what will you say? Which one is more accurate? Can you tell me that? So we can say that what? Since the standard deviation of A is small, so we can say what? A is more precise. Student A is more precise. Or student A, let me just say, has high precision. Student A has high precision. Why? The standard deviation of A is low. And student B, what am I writing? Sorry. Student A has high precision. Please, sorry about that. So student A has high precision. Why this one student B has low precision? If you observe, you can see that even without solving this thing, you can even look at it from your look at it here. 28 points, all these that I'm having here, if you look at the difference between them, you'll be getting difference like 0.01, 0. So you can see that this one, they are more precise because they are not far from each other. But if you look at this one, you can see they are somewhat far from each other. If you look at it, they are somewhat far from each other. So you can see that what? A has high precision, or A is more precise. And that is it. And that is the end of the video. But before I leave, let us summarize some formula we actually need under this. So we need some certain formula that are very, very important. So let's summarize the formula we need here. So the first one is that whenever you are asked to calculate your error, your error is equals to what? Your measured value minus the true value, or your mean minus the true value. Okay, so that is it. So we always regard the sign. If you have minus, put minus. If you have plus, put plus. So that's it. So also, to find relative error, what do we say? Relative error is what? Our absolute error over the true value. So in percentage, you multiply by 100. That's in percentage. In parts per thousand, you multiply by 1,000. That's in what? In parts per thousand, multiply by 1,000. So it depends on what you're asked to look for. Now, let's go. The next one is this. This is the relative error. So to find relative accuracy, what formula to find relative accuracy is what? Your measured value over the true value. Now, it is not error. Your measured value over the true value. Or if you are taking replicate measurement, you say your mean over the what? Over the true value. So that is your relative accuracy. So if you're asked to find relative accuracy in percentage, you multiply by 100. In part per thousand, you multiply by 1,000. So that is it. Okay. And that is that about that. And take note of something that is very, very important. There's something we always do, and that is to reject some values given. Whenever we have some measurement to be like this, for example, 1.01, we have measurement like 1.01, 1.12, 1.00, 1.13, and we now have values like 4.25. Look at this value. Whenever you are given this in chemistry to solve for, whether you want to find the absolute error or something like this, take note that we are going to reject this value. Here, you reject this value. That is, you will cancel out this value and solve for this. Okay? Because this is like too far from the set of data that you have. So follow my video for more update like this. So I'll still release more video on theory of errors, on how to solve some questions on it. So thanks for watching. Try to subscribe, like, comment, and share. Thanks for watching. Love you guys.